So in this video, we're going to import actually 2D data. I'm going to import a 3x3 matrix. As you can imagine, if you have, say, a large amount of 2D data, you'd have probably more than just 3x3, but I wanted to type this in by hand to show you. So let's take a look. This is my data. It's called 2d.text, and it is in fact a matrix given in 2 dimensions. So I have my rows and my columns, and you'll notice also I used a comma to separate my values here. This is called a comma-separated values file for reasons that hopefully are clear. There's values that are separated by commas, and they're numeric. And MATLAB has a lot of ways to read this comma-separated value, or CSV file. We can use DLM read, which is what we're going to do. But if you're wondering, there's actually a function called CSV read that specially reads CSV files. There's no big difference between the two, so we're going to just stick with DLM read because it is more general. Now, MATLAB is, like I keep saying, very, very intelligent. So MATLAB will actually read the first data up until the new line and then recognize there's a new line of data coming in and put it into a new row in a matrix when it reads it in. So let's take a look at what I'm talking about, and let's see how we can actually read this file. So I have a file called 2d.text, and we're going to read it into a matrix called M. So M equals 2d, I beg your pardon, DLM read 2d.text, and now because the delimiter is not just white space or spaces, I have to tell it what it is, and it's a comma. So I give it a single quote, comma, single quote. Okay, so what this says is read the file 2d.text, and all the variables are separated by the comma, and MATLAB intuitively understands that the new line character then means give me a new row. So I'm going to run it. And again, it ran, everything is fine. And let's take a look at my matrix M. And so MATLAB read it in, it gave me the appropriate dimensions of my matrix and everything else. It's really, really great. And I can do things on my matrix. For example, I can invert it. So I can say INVM, which inverts a matrix if you were wondering, and I hit enter, and it gives me the inverse of the matrix. And because I can't really do linear algebra that quickly in my head, I'm going to trust that MATLAB is telling me the right thing. Okay. So now we were able to do maxes and mins on 1D data, and MATLAB actually allows us to do maxes and mins on 2D data, but if you just use max and min functions on their own, you're going to see something a little different than you might expect. So let me type in these two things. So first I'm going to clear my console, and I'm going to just make this a bit bigger because I want you to see what's going to happen when I start just calling max and min. So here's what M is. I want to make sure that's clear as well. And if I say max of M, what I actually get is a vector of maximums. Now let's see where these numbers are coming from. I have 7, which appears to be the largest number in the first column, then 6, which is the largest number in the second column, and then 8, which is the largest number in the third column. Now it just so happened that my data was set up so that the second row here happens to contain all the maximum data. Let's change that. So if I want to change, let's say this 3 here to 50, for example, to make it really a maximum, I want to access the elements in that array, and in particular I want to access the matrix at 3, 3. So all I need to do is say M 3, 3. So this is how you access multidimensional arrays, and you just give it the 2 indices that you want, the row and then the column in that order. And I want it to be 50, so I say equals 50. Now when I hit enter, we're going to see the entire matrix M coming back out, and as you can see, I have a 50 here. Okay, so that's the way that you're going to change things in a big 2D matrix, and then if you actually work with, say, 3D or 4D data, also the multidimensional data as well. So let me clear my console. I'm going to put M back up here, and now I'm going to say max of M, and take a look at what changed. So I get 7, 6, and 50 now. So it is in fact finding me the largest number in each column and returning it to me as a vector. Now this might be what you want, but almost always it isn't. What you normally meant to say is, no, I want the maximum of M itself. I wanted the biggest number. And so for 2D data, what you have to do is actually call max twice. And to do that, you say max of M. So it's basically a function call within a function call, and when I hit enter, I'm going to see the number 50. So just be aware of that when you have multidimensional data. Let's take a mean of M and let's see what MATLAB does for that. So if I say mean of M, then once again I get this vector of means, and that isn't what I meant to do, right? Normally what I want is to find the average of the entire matrix itself, for example. Maybe there are a bunch of different grades of equal weight, for instance. And so again, I'd have to call mean on the mean. So I'd have to do a double function call, mean of m. And now I in fact get the mean of the matrix. So you just need to be a little bit careful when you are working with multidimensional data. Sometimes you might just want that vector. You might want to know, say, a vector of maxes, or you might want to know what was the largest number in each of the columns, and that's perfectly fine. You can just call max once, or mean, again, you can call mean once and get the mean of all the columns. But if you actually meant to find the absolute maximum of the matrix, the absolute minimum, or the mean of the whole thing, you actually have to do a double function call. And that is a little bit confusing for some students, so be aware of that. That is absolutely something you have to do. Otherwise, though, when you're doing a read of data, you can use DLM read to do more or less anything you want, as long as your data is actually structured like MATLAB expects. So in our case, I wanted to read a 2x2 matrix, or 3x3 matrix, sorry, and so I gave it a 3x3 matrix in my file, and MATLAB could absolutely handle that, put it into a numeric variable, and now I can start doing math right away.